Hello students, welcome back to the chapter Polymers. In the previous video lectures, that is video lecture 1 and 2, we learned introduction to polymers and free radical mechanism of polymers. In today's video lecture, we are going to learn the preparation of Nylon 6 and Nylon 6,6, one of the most important preparation. Along with that, we are going to learn Terylene or Dacron and bakelite preparation. Along with that, we are going to learn melamine and urea formaldehyde polymer. Let us begin our today's session. Nylon. We heard this name nylon in many places in one of the polymer, and the name is derived from the two great cities, New York and London. The preparation of this type of polymer is simultaneously done in these two cities, New York and London. The great gesture, the polymer which is prepared is named as nylon. NY stands for New York and LON stands for London. And this nylon, which is formed by the condensation polymerization. It is not a addition polymerization, it is a condensation polymerization, where some of the smaller components are removed as a byproduct. And remember, this is polyamide fiber, that is, there is a presence of amide linkage CONH2, and which is formed by the combination of acid and amine. So the acid and amine, which we can understand with this one, RCOOH, it is a carboxylic acid, and amine, it is a primary amine, RNH2. If you remove the water molecule from this, there is a formation of a linkage between carbonyl carbon and nitrogen of amine that leads to the formation of CONH linkage, and that linkage is known as amide linkage. There are of two types of nylons. First is nylon 6 and the second is nylon 6,6. Let us learn the first one, nylon 6. So we have a structure of omega amino caproic acid. So there are total 6 carbon atom, and the 7th group is amine group. So it is a amino acid where there is a presence of acidic group as well as amine group. Total there are 1, 2, 3, 4, 5, 6 carbon atom, and the 7th member is amine nitrogen atom. The same thing we are going to do, that is a removal of water molecule from here, that leads to the formation of amide linkage. So the process of removal of water is known as dehydration, and there is a new bond formation between carbonyl carbon and nitrogen of amine group. And the component, which is total 7 membered ring, out of which there are total 6 carbon atoms and 1 is nitrogen atom. We can count from here, carbon number 1, 2, 3, 4, 5, 6. So there are total 6 carbon atom. Out of 6 carbon atom, there are 5 CH2 group and 1 is C double bond O carbonyl group. You can call now it as ketonic group, and this is NH group, that is amine, and the bond formed between CO and NH, that is called as amide linkage, and the name of this 7-membered ring is caprolactam. Dear students, please remember, the monomer for nylon 6 is caprolactam. When the bond between carbonyl carbon and nitrogen, if it breaks at the temperature of 533 Kelvin in the inert atmosphere of nitrogen, that is N2, now the ring becomes open chain, that is C double bond O. There are 5 CH2 group and NH group. If this group repeats n times, if you have taken n times this caprolactam, and this ring is going to appear for n times, and the component or the polymer which is formed is known as nylon 6. We can remember from caprolactam to nylon 6 preparation. Moving to the next part, that is the preparation of nylon 6,6. Monomers which are used in nylon 6,6 are again acid and amine. The acid which is used is adipic acid. The structure is, it is dicarboxylic acid, and which contains 4 CH2 group, C double bond O OH on either side, and middle 4 groups are CH2 groups. So again it is a 6-membered carboxylic acid. Moving to the second monomer which we are going to use for the preparation of nylon 6,6 is hexamethylene diamine. As the name itself indicates, it is an amine group. So the combination of acid and amine leads to the formation of amide group, CONH group. So the structure for hexamethylene diamine, as the name itself indicates, there are hexamethylene, there are total 6 CH2 groups, and diamine on either side of the structure we are going to have NH2 groups. The name you learned, nylon, it came from two great cities, New York and London. And as there is a presence of 6 carbon atoms in the monomer, and in both the cases there is a presence of 6 carbon atoms, we can call it as nylon 6,6. So with this hint you can remember nylon 6 means there is only one monomeric unit and which contains a total 6 carbon atoms, whereas in nylon 6,6 there are 2 different monomers and both are having total 6 carbon atoms, out of which one is acid and the other is amine. Moving to the next one, properties of nylon 6,6. They are strong and extremely tough. Second one, they are resistant to dilute acids and bases, and they possess great elasticity. Examples for nylon 6,6. First one, they are used in the textile industry. Second, they are used in the preparation of fishing nets. Next, the third one is roofs for parachute, etc. Moving to the next part, that is preparation of nylon 6,6. So as we know, there are 2 monomeric units which are used in the preparation of nylon 6,6. That is, the first one is adipic acid and the second is hexamethylene diamine. Adipic acid, total number of carbon atoms are 6. Out of 6, 2 are C double bond O OH group, that is carboxylic acid group, on the adjacent or the terminal positions of the chain, and there are 4 CH2 groups which are the chain members. Coming to the second monomeric unit, that is hexamethylene diamine, there are total 6 CH2 groups, and on the either side of these CH2 groups there is a presence of 2 NH2 groups. So the structure is here, adipic acid and hexamethylene diamine. As we all know, it is a condensation process. There must be the removal of smaller molecules like water, carbon dioxide, etc. So when these monomeric units, that is adipic acid and hexamethylene diamine, they undergo rearrangement. If you have taken n times adipic acid and n times hexamethylene diamine, we can expect the polymer n times the structure or the repeating unit. Dear students, please remember it is a condensation process where the removal of water molecule from the components takes place, which is leading to the formation of new linkage, that is amide linkage. So the rearrangement we can understand here. The hydrogen atoms are going to interchange from carbonyl carbon OH group to the nitrogen atom. So you can see here there is a presence of OH group and there are presence of NH2 group. Now in the next structure at 373 Kelvin, there is only oxygen atom, and the hydrogen atom which is present along with oxygen of carboxylic acid is now along with nitrogen of amine. and as there is an imbalance, there is a formation of charges. The nitrogen atom which gains the hydrogen atom gets a positive charge, and the oxygen atoms which loses the hydrogen atom, they get the negative charge. And there is a formation of bonding, and we can call this, as it contains plus charge and the minus charge, we can call this as nylon salt, which undergoes further rearrangement at the temperature 553 Kelvin in presence of inert atmosphere of nitrogen. So you can observe here, there is a removal of water molecule. So H2O molecule, you are observing that it is going to side now. So the oxygen atom is also sided. And so how many water molecules are removed? It is n minus 1 number of water molecules are removed. So where is n? N is the number of units which you are going to take in the beginning of the reaction. Or adipic acid, n times hexamethylene diamine, n times that n, if you substitute here, one water molecule less than the total number of adipic acid or the hexamethylene diamine, that much amount of water is liberated. Okay, so the final structure what we are going to get, it is the nylon 6,6. So you can expect the new bonding formed between carbonyl carbon and nitrogen of amine group. So the structure formed is nylon 6,6. You can see here, simple thing, C double bond O as it is, CH2 4 times as it is, C double bond O as it is. So OH group from either side it is removed. So coming to the next structure, NH group as it is, CH2 6 times as it is, again the NH group. So one of the hydrogen atom of amine group, it is removed along with the OH group. Okay, so it is going to form nylon 6,6. So as it is a condensation, there must be the loss of some water molecule or carbon dioxide, etc. So depending upon the structure, now here water molecule is removed and the bond formed is amide bond or amide linkage. So this is the n times repeating units, hence it is also the n times repeating unit, and it is nylon 6,6. Moving to the next part, that is the preparation of terylene or dacron. Terylene is also known as polyester or dacron. So the monomers which are used are ethylene glycol. So structure of ethylene glycol, CH2OH, CH2OH. Another monomer which is used in the preparation of this dacron is terephthalic acid. So you know phthalic acid, it is a 6-membered benzene ring and the adjacent 2 carbon atoms are containing COOH group, that is ortho dicarboxylic acid is phthalic acid. Now it is a terephthalic acid, means the position of COOH groups must be different. So now in this case the 2 COOH groups are present at para position to each other or 1,4 position. So the monomeric units which are used in polyester are ethylene glycol and terephthalic acid, and these two are heated at 503 Kelvin. We can get terylene, polyester or dacron. And the catalyst which we are going to use here in this preparation of the polymer is zinc acetate and antimony trioxide. Let us learn the preparation. So we have ethylene glycol, CH2OH, CH2OH, and which is treated along with the terephthalic acid. Again there is a removal of water molecule, you can see the color change, OH group and H. So the reaction between ethylene glycol and terephthalic acid, we are going to get the polymeric unit, that is terylene or dacron. If you have taken n times ethylene glycol, n times terephthalic acid, we are going to get 2n times of water. So how many water molecules are removed? Double the quantity of ethylene glycol or terephthalic acid. We are going to get the water molecule, and as water molecule is a byproduct formed, this preparation or preparation of terylene, dacron also come under condensation polymerization. So hydrogen atom is removed, oxygen remain as it is, CH2 2 groups remain as it is, oxygen, hydrogen is removed, and there is a presence of COO group. So you can consider this C double bond OO group, that is ester group formation. So the linkage which is formed in Terylene or Decron, it is a ester group, hence it is come under polyesters. Going to the next one, preparation of bakelite, one of the most important preparation, bakelite, which is also known as formaldehyde and phenol polymer, which is also known as copolymer of phenol and formaldehyde. So you are very familiar with the structure of formaldehyde and phenol. Phenol is C6H5OH, whereas formaldehyde is HCHO or CH2O. When n times of these components, that is phenol and formaldehyde, are reacted together, there is a removal of water molecule, again come under condensation, polymerization. There is a formation of linkage between CH2 group of formaldehyde and carbon of benzene ring by the loss of water molecule. The OH group of phenol is ortho and para directing, hence the CH2 group has to attack either to ortho position to OH or para position to OH. So the CH2 group is going to attack either to ortho or para. So as the OH group of phenol is ortho and para directing, we are going to get different compounds. One is ortho hydroxymethylphenol, second is ortho and para dihydroxymethylphenol, and also 2,4,6 trihydroxymethylphenol. So we will go with respect to the one component, that is ortho hydroxymethylphenol. We have C6H4OH CH2OH, which can also be written as C6H1234 C6H4OH CH2OH. Just we are representing the hydrogen atom of one of the position in benzene ring. Process is polymerization. So there is a removal of water molecule takes place from the two successive components, that is orthohydroxymethylphenol, another orthohydroxymethylphenol. So there is the presence of OH group and a hydrogen atom, removal of water molecule, again come under condensation process. Condensation process, removal of smaller molecules takes place or byproducts are formed, and the polymeric component, which is formed by the combination of these two subsequent groups, leads to the formation of new type of component, that is known as NOLAC, which is linear polymer, and it is not a bakelite, it is NOLAC, which is the one of the important component which is used in the preparation of bakelite. As we have taken n times orthohydroxymethylphenol, we are going to get a structure linear polymer NOLAC. This NOLAC, which is treated with formaldehyde, leads to the formation of bakelite. There is a removal of two hydrogen atoms, there is a combination. So in this position there is a presence of CH2 groups. So from where these CH2 groups are taken, we have taken the CH2 group from here. So those hydrogen atoms can go along with oxygen atom. We can see that process once again. We have one NOLAC structure, another NOLAC structure, para position to OH group, two hydrogen atoms, one oxygen atom and two hydrogen atoms, one water molecule is removed, one oxygen atom, two hydrogen atom, another water molecule is removed. So whatever the CH2 group is left, that is going to take the position in this. So we can write that one as like this, CH2, CH2. And the component which is formed, or the polymer which is formed, is bakelite. It is cross-linked polymer. Moving to the examples. Bakelite, which is used in the preparation of electric switches, plugs, CDs, etc. Moving to the last part of the video lecture, preparation of melamine and also the preparation of urea formaldehyde polymer. First one, melamine, which is also known as melmac. Monomer for melamine we are going to learn. We have a benzene ring here. Remove hydrogen atoms and the adjacent carbon atoms. Place nitrogen atoms. The 3 carbon atoms which are present as a ring members, now they are containing NH2 groups instead of hydrogen atoms. So those NH2 groups are going to combine with formaldehyde group, and that leads to the formation of new structure, that is an intermediate, resin intermediate. And that resin intermediate, which is going to take N times, and the removal of water molecule, dehydration, and the process is known as polymerization. What we get is melamine or melmac. We learn this once again. Formaldehyde and a benzene ring. 1, 2, 3, 4, 5, 6 carbon atom, and there are 6 hydrogen atoms. Remove 3 adjacent carbon atoms and all the hydrogen atoms. Place 3 nitrogen atoms as a ring member. The carbon atoms which are present, to that we place NH2 groups. That reacts with formaldehyde. Removal of water molecule, that process is known as dehydration, and which is going to form an intermediate component, that is resin intermediate. After the removal of water from N times of the component, you can see here there is no other group which is going to continue, that is again it is a cross-linked polymer. So dehydration, polymerization leads to the formation of melamine or melmac. Uses of melamine or melmac, we are going to use these for the preparation of crockeries. Coming to the next one, urea formaldehyde polymer. So as the name itself indicates, the monomeric units are urea, NH2CO NH2. When this reacts with formaldehyde, CH2O, reaction leads to the removal of water molecule, or the hydrogen atom of urea is going to attach now with oxygen atom of formaldehyde, and the carbon atom is going to bind to nitrogen atom. So NCH2O group we can observe. Here it is, NCH2O group we get. Such NCH2O groups can be formed with other 3 hydrogen atoms which are linked to different nitrogen atoms. So the process continues. There is a formation of CH2O. Now the third one, hydrogen atom is going to attach to CH2O, and the carbon atom is going to take CH2OH. So it is formed. And the fourth one, the last one, you can see here, hydrogen atom binds to CH2O, and the CH2OH which is formed is going to bind to nitrogen atom. So there are total 4 CH2OH groups. Instead of hydrogen atom, now we are having CH2OH. This urea and formaldehyde combination leads to the formation of such type of compound. This compound is an intermediate which is going to react again with another molecule of urea, CONH2NH2 or NH2CONH2. So there is a removal of water molecule, again a condensation process, removal of water molecule. So how many water molecules are removed? Total 4 water molecules are removed, and that if you have taken N times, then you are going to get urea formaldehyde polymer. So the structure what we are going to get, it is like this: NH2CO NH2 and a formaldehyde H C double bond OH leads to the formation of this type of component. Here we have NCH2OH we were having. After the removal of water, another molecule combined to form cross-linked polymer. Uses: it is used in the preparation of molded plastics. Dear students, hope you enjoy the session. Thank you very much.